Welcome to PHAROS Guardian, an on-device drug safety companion for community health workers worldwide. Built for the Kaggle Gemma 4 Good Hackathon 2026, PHAROS Guardian demonstrates 4 of Gemma 4's most powerful capabilities: multimodal vision, native function calling, multilingual generation, and edge deployment, all in service of protecting the world's most vulnerable patients. More than 2 million community health workers operate in low-resource settings across Africa, South Asia, and Latin America. They dispense medications every day, but they have no reliable way to identify a drug from its label, especially in unfamiliar languages. They have no access to adverse drug reaction risk profiles without internet connectivity and months of training. Drug-drug interaction checks simply don't happen in the field. And when a warning does exist, it's only available in English, not in Hindi, Swahili, French, or local languages. The result: preventable adverse events that harm the patients who can least afford them. PHAROS Guardian solves this in 3 seconds. A community health worker photographs a medication label. That's it. The system pre-processes the image with CHWs contrast enhancement, passes it to Gemma 4's multimodal vision to identify the drug and extract dosing information, queries the FDA FAERS signal database for real proportional reporting ratio scores, checks for dangerous interactions with other medications the patient is taking, and generates a complete safety report in 4 languages, all without touching the internet. The entire pipeline runs on a T4 GPU. No cloud subscription. No per-query cost, free on any device. PHAROS Guardian showcases 4 core Gemma 4 capabilities. First, multimodal image and text. In Cell 9, Gemma 4 receives the medication label photo alongside a structured prompt, and returns the drug name, brand, dose, and a confidence score as structured JSON. Second, native function calling. In Cell 12, a 6-turn agent loop gives Gemma 4 access to 3 tools: look up ADR signals, check interactions, and assess patient risk. The model autonomously decides when to call each tool. Third, multilingual generation. Cell 13 produces plain language recommendations for community health workers in English, Hindi, Swahili, and French in a single pass. And fourth, edge deployment. The 4 billion parameter E4B model fits within T4 VRAM, runs in about 15 minutes on Kaggle's free tier, and requires 0 internet at inference time. Here's a real safety report generated by PHAROS Guardian. The patient is a 68-year-old with atrial fibrillation and hypertension, currently taking aspirin and amoxicillin. The medication label photo shows warfarin. Gemma 4 identifies the drug with 100% confidence. The risk level is immediately flagged as critical. 4 ADR signals are retrieved from the FDA FAERS database. Intracranial hemorrhage with a proportional reporting ratio of 8.43, 8 times the background rate. Major bleeding event at 6.71. Skin necrosis at 5.1. And INR fluctuation at 4.2. 2 drug interactions are flagged. Warfarin plus aspirin is a major interaction. Concurrent use significantly increases bleeding risk. Warfarin plus amoxicillin is moderate. INR should be monitored within 3 to 5 days. Finally, Gemma 4 generates plain language recommendations for the health worker in English, Hindi, Swahili, and French, all in a single multilingual inference pass. The signal database covers 29 drugs across 12 therapeutic areas, specifically chosen for community health worker settings in low and middle-income countries. The catalog includes analgesics like paracetamol and ibuprofen, cardiovascular drugs including warfarin, digoxin, lisinopril, and amlodipine, antibiotics critical for LMIC settings like cotrimoxazole and ciprofloxacin, the antimalarial artemether, the antifungal fluconazole for HIV-associated infections, and the antiepileptic phenobarbital. All drugs except the demo agent Cardivex use real PRR scores fetched from the FDA FAERS API. Synthetic fallback signals activate automatically when the network is unavailable. The architecture is straightforward and fully offline at inference time. User input, an image, path, URL, or demo file, flows into the image preprocessor, which applies CHWs contrast enhancement and resizes the image for Gemma 4. 2 parallel paths run simultaneously: Gemma 4 E4B for multimodal drug identification, and the SQLite signal database containing real FDA FAERS data and curated interaction pairs. Both outputs feed into the function calling agent loop, where Gemma 4 autonomously queries the database through 3 registered tools. The final output is the multilingual safety report. No fast API, no network, no external dependencies at inference time. Pure SQLite and transformers. The impact is measurable and immediate. Without PHAROS Guardian, drug identification requires manual label reading in unknown languages. With PHAROS, Gemma 4 visual identification takes under 3 seconds. Without PHAROS, ADR signal access requires internet connectivity and 6 months of training. With PHAROS, it's an offline SQLite bundle. Without PHAROS, interaction checks simply don't happen in the field. With PHAROS, they're automatic at every scan. Without PHAROS, warnings exist only in English. With PHAROS, English, Hindi, Swahili, French. The potential reach: over 2 million community health workers in the places that need it most. At zero cost. This is what AI for good looks like.